Hello, my name is Beth Dixon, and this is part 2 of a video series based on Vicki Borlaug's PowerPoint presentation on the confidence interval for the mean. I wish to thank Mrs. Borlaug for allowing me to use this PowerPoint to make this set of videos. In this set of videos, we will concentrate on adding a graphical display to our confidence intervals to help them make better sense. In part 1, we looked at this example. The length of parts produced by a manufacturing company is normally distributed with a mean of 700 centimeters and a standard deviation of 10 centimeters. And even though that's a fact, it's not a known fact. It's kind of hidden there, but nobody knows it. And Miss Borlaug picked my name. Oh, aren't I flattered? Beth does not know the mean or the standard deviation. She wishes to estimate the mean length. And she takes a random sample of 6 parts and measures the lengths in centimeters, and the results are given below. And in part 1 of this video series, we constructed the 90% confidence interval, we wrote a sentence interpreting the confidence interval, and we graphically displayed the confidence interval for the mean parts. And so we're going to just kind of quickly go past these screens. I guess you could pause on these screens if you didn't watch part 1 but are comfortable in creating and doing that part of it. And we're going to pause here and kind of review. We got the confidence interval and we looked at the graphical display of it, and we noticed that 700, that mean of our population, did fall into that confidence interval that we created. And now we're ready to move on to the next part, or the next exercise. And this is an exercise that Ms. Borlaug generally assigns for you to do, but we are going to kind of work through parts of it. And it's still based on this same example that we just did. So that's kind of why I wanted to go back through and read that example. So in this case, let's say after I've taken my sample, you are not convinced that I've discovered the true interval for the mean, or you're not convinced that the mean is actually in my interval. So you're going to take a sample yourself, and here is your random sample. Now, there are computer programs that can generate these samples, or if you were really on the job, you may actually do what I just said. You may take a sample, or they may take a sample off of every line or for every shift of a manufacturing process. But for our purposes here, this is your sample, and you may want to pause here and complete the work that we did in part 1, and that is to construct the 90% confidence interval for the mean length of the parts, write a sentence interpreting the confidence interval, and graphically display the confidence interval for the mean parts. And your random sample is 693.3, 691.7, 681.5, 706.8, 690.7, 712.4. When you're through, be sure that you graph it on that same normal curve. Now for exercise 2. In exercise 2, again, we're still on that same setup, and we're now going to pretend that a lot of people have taken random samples. Maybe everybody that manufactures this particular part. So Jill, Troy, Mary, Vicki, Bob, Jack, Beth, and you have all taken random samples from this population. And each person constructs a 90% confidence interval for the mean length of parts. And the results are shown on the next slide. So here are the results. Notice if you wish to check your answers, the ones at the bottom of the screen in red are the answers to exercise 1. So here are the results. And we're going to fill in the blanks for the following questions. These samples were taken from a normally distributed population with a mean of, well, what did we say the manufacturing population had a mean of? Well, it was a mean of 700 and a standard deviation of 10. So I'm kind of just giving you those answers. Now, do all of these confidence intervals contain the true mean of the population, mu equals 700? Well, let's look at it. There's 700. Jill's interval does contain 700. Troy's interval does contain 700. Mary's interval does contain 700. Vicki's interval does not contain 700. Bob's interval does. Jack's does. Beth's does. And yours does. So you have the information you need to answer. Do all of these confidence intervals contain the true mean of 700? And if not, whose confidence interval or intervals do not contain the mean of 700? In general, if random samples are taken over and over again, 90% and 90% confidence intervals on the mean are constructed, 90% of the time the true mean, mu, is contained in the confidence intervals. Let me say that again. In general, if random samples are taken over and over again and 90% confident intervals on the mean are constructed, 90% of the time the true mean mu is contained in the confidence intervals. When people say that there are 90% confident, it means that there's a 90% chance that they are correct and a 10% chance that they're wrong. And lastly, think of this last question. Does a 90% confidence interval on the mean length describe where 90% of the individual lengths of parts fall, or gives an interval where there's a 90% chance the mean length of the parts will fall? Now we have some exercises. And as you look at exercise 3, it gives you, and I'll let you pause and read this, but basically it's asking if there is a detectable difference. And by a detectable difference, that means is there a possibility that the mean could be the same? And if there is an overlap, that is possible. If there is not an overlap, that would not be possible. Exercise 4. And exercise 5. Well, it says 5 and then it said 4 again. I don't know what numbers. Just do the problems. Thank you for watching, and I hope this was helpful.